So we're continuing what we did before. And today what we're going to do is we're going to use what we did yesterday or the day before. And we're going to use the information that we find to compare two groups of data. So what we call that is using measures of spread to compare sets of data, right? So all that stuff like standard deviation, range, all that stuff, collectively, those are called measures of spread. It shows you how spread out your data is. We're going to use our calculators to come up with the same, like it's the same process, but yesterday we were given a lot of information, but we only took the standard deviation. Today we're going to do a little bit more. All right, so take a look at this example here. It's about metabolic rate, which is the rate at which the body consumes energy. Okay, and here we have a study from two different groups of men. And the question is, which group has a greater variation? So what we're going to do now, we have two data sets. So what we're going to do is we're going to go in the calculator, back in spreadsheets like this, and what you're going to do is you're going to enter in column 1 all of the data from group 1, and then you're going to enter the group 2 data in column 2. Okay, so let's go ahead and do that. Go ahead and take out your calculators. Go ahead and plug all that stuff in. Yes, go in the spreadsheets and we're going to plug it in. So in the first column, it's going to be 1507, 1744, and so on. So let me just take a minute to put that in here. So we then have to do what we did yesterday, but for each of the columns on their own. So a cool thing here is if you keep going, pressing the up arrow, it goes up, right? Now when you're here on row 1, if you go up, 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 eventually it highlights the whole column for you. Highlighted column 1, and I want to do what I did yesterday. So basically menu, statistics, stat calculations, one variable statistics. And now how many lists do we have? 1. Okay, now it asks you, is this the list? Yes, it is. And here it says, where do you want the results? Well, now we don't want it in column B anymore, because in column B, I have other information. So why don't I say, let's put it in column, I don't know, D. Oops, I don't want this. So let's put it in column D. So press OK. Here, no, it doesn't matter. All right, so look at all the stuff that we found here. Okay? Yeah. So yesterday, all we were looking for was the standard deviation. Today, we're going to look at some other stuff. So if you go down here, you also have a mean, right? The mean is 1603. That first one, X bar, you have the mean. So I'm going to extract from here the mean, and then also I want the median. So let's go see where the median is. That's the median, all right? 1591.5. So here I'm going to write down that my mean is 1603.9, and then the median is 1591.5. What I also want from here is to calculate the range. So we're going to do that manually. What's the highest number here and what's the lowest? The lowest looks like is 1429, right? And what's the highest one? 1764. Yeah. So the range is 1764 minus 1429, which is 335. And I also want standard deviation. And, that's S in the calculator. That's the S value. Where is it? How much was it? Oh. Here. 100.2. All right. Now I want to go back to the calculator and I want to do the same thing, but this time for column B. So scroll up, 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 up until you highlight the whole column. And again, menu, statistics, stat calculations, one variable statistics, number of lists 1. And now is your list column B? It is. And where do you want the results? Well, I don't want it in C. Maybe let's do it in like G.
Yeah, because then you get that like.
Yeah, I want. Okay, so let's do it in G. So now, yeah, the mean is 1604, and what's the median? 1605. So let's write those down. Mean, median, yeah. What's the range? Uh-huh. Mm-hmm. And that's 247. And what is our standard deviation? 54.6. Okay? All right, so back to the question. The question was asking which has a greater variation. All right, so in order to find the group with the greater variation, so basically in which group was there, did the numbers vary to a greater extent? Well, you have to look at a couple of things. One thing you can look at is compare the mean and the median within each group. So look at the mean here. And then look at the median. The mean, the average is 1,603. The median is 1,591. Here, look at the mean and look at the median. What do you notice between group 1 and group 2?
It's different. They're very different.
How so?
Well, the median is bigger than the mean in group 2.
Right, but how close are they?
1 apart in that one.
And here?
And
Very, yeah, further apart here. So the mean and median are very close to each other for group 2, but here they vary a lot more in group 1. Another thing we want to look at is take a look at the range. There is a much bigger range in group 2 than there is in group 1. Third thing we're going to look at is the standard deviation. The standard deviation here is much bigger, and the standard deviation here is much smaller. What does that mean? That means a particular data value will be a lot farther from the average in group 1, but a particular data value in group 2 will be closer to the mean. So because of all of these put together, we can conclude that group 1 has a greater variation. Okay? So that's how we do that. All right, so let's move on to frequency distributions or frequency tables. Okay, a frequency distribution shows how the data is divided into categories, all right? And so you have a listing by classes and categories. So let's do an example here. The winning scores for the first 42 Super Bowls are shown below, right? These are the winning scores. So now what you want to do is we want to make a distribution table. So to do that, first you want the range of the data. And if you look here at the range, the smallest number is 14 and the largest score is 55. All right? So that's the range. So the range goes from 14 to 55. So because you need that, because you need to create a scale, and you want to know that, okay, your numbers have to go from 14 to 55. Now you have to determine classes. So what you're going to do is you're going to take this range, 14 to 55, and you're going to divide it into equal classes. So you can, it's like calibrating the x-axis. You have to go from 14 to 55. So now you have to decide, are you going to go by 5s? Are you going to go by 10s? Are you going to go by 1s? Right? So in this case, what we're going to do is we're going to have classes of equal length like this. So we're going to go from 10 to 19, 20 to 29, 30 to 39, and so on. Basically, eventually, we're going to do like a bar graph, okay? And then once you have your classes, you have to tally the data. So here's what we do. We determine that the classes are 10 to 19, right? So you write that here, 10 to 19, 20 to 29, 30 to 39. And now you want to tally them. So for example, this first number, 35, goes in the 30s, so you put a tally mark there, okay? 33 goes in the 30s, you put a tally mark there. 16 goes in the 10s, you put a tally mark there. So at the end of the day, you have tallied, right, how many scores are between 10 and 19, how many from 20 to 29, and so on. Okay? Then what you do, okay, so this is it's called the frequency. You basically like count your tallies, so 5, 16, 15, 4, and 2. This should be the same number as you have data, right? So this was the first 42 Super Bowls. So there are 42 scores. So that column here should add up to 42. Do you see what we did? Okay. So basically, it's like I'm separating how many scores, how many times were the scores between 10 and 19. So basically, like look at this here. Okay, how many of these numbers fall in the category of 10 to 19?
Oh, so 5. So it's how many fall in those?
Yeah.
Okay, now I get it. Sorry.
It's okay. So that's the frequency, so 5, 16, and so on. Now, the relative frequency is the frequency over the total. 5 over 42, 16 over 42, 15 over 42. So this is the frequency over the total. You can express it either in fractions or decimals. Okay. It's important that when you figure out what these numbers are going to be, these class boundaries, right? So the class boundary is 10, 19, 20, 29, 30, 39. It's important that there are no gaps in between. So if you stopped here at 19, that you continue at 20, right? So you don't go like 10 to 19 and then 23 to 27. You see that? There shouldn't be any gaps in between. Okay. What are class midpoints? That's the middle value of each of the classes. Okay? So here, let's determine for this. So for each class, it goes from 10 to 19. How many numbers is that? That's 10. Okay? Okay, what are the lower class boundaries for each one? The lower class boundaries are 10, 20, 30, 40, and 50, right? What are the upper classes? Yeah, 19. Okay, the class boundaries are the numbers in between one class and another. Yeah, so no, so you have to do this. So the one between 19 and 20, let's say, is 19.5. You know what I mean?
Oh, okay. But it could be 19.1.
Yeah, we usually go in the midpoint.
29.5.
Yeah.
39.
And so on, yeah. And then the class midpoints are the mid numbers in between, let's say, 10 to 19. So that's 14.5, 24.5, 34.5, 44.5, and 54.5. Okay, now we can use that to draw a histogram. What is a histogram, you say? It has nothing to do with history, but it's a graph consisting of equal bars adjacent to each other without gaps. All right? Okay. In a histogram, the horizontal scale represents the classes. The heights are the frequency values. Okay? So basically, a histogram is everything that we had in this frequency table, but a more graphic version of it. Okay? All right. So take a look here.
Oh, okay.
Right? That's a frequency. So look at what look at these. These are the classes 10 to 19. How many was in 10 to 19? 5. How many were from 20 to 29? 16. How many from 30 to 39? That many, and so on and so forth. Okay? So here, this is the frequency. Okay, so it's when you look at the frequency, this shows actual number of scores. Okay, so of point number of points. So there are like 5, 6, 16, and so on. This is the relative frequency, and the relative frequency, we've basically graphed these values. You see that? What that shows is what the relative frequency graph shows is how does the quantity compare from one class to another. So you can clearly see that there is the smallest number in this class, and you can see that these two are the highest, and you can even see that, you know, the second one, for example, is at least 2.5 times bigger than the first, right? So this shows a comparison between classes. All right? Okay, one other thing we're going to talk about is quartiles. When you hear the word quartile, what number comes to mind?
Core, like.
When you hear the word quartile, what number comes to mind? 4, like quarters, right? So quartiles are when you divide a set of data into 4 equal parts, okay? So for example, if I had test scores for like 50 people, I would say, okay, the bottom fourth scored, these were like you divide the scores into 4 and you say, okay, these are the ones in the bottom 4, the second 4, and then these are the scores on the top 4, okay? So we're going to divide into 4 equal parts. What you do is first you go with the median. Remember, the median is exactly in the middle, okay? So that's how you first divide it. And then from that, you take the lower half and you divide it in 2. You take the upper half and you divide it in 2. Now, all of a sudden, I have 4 quartiles. 1, 2, 3, 4 regions. Okay? Now, this number here, which is the first partition, I call that Q1. This number here, which was the median, but it's also the second partition, I call it Q2. And here, this is the third partition, I call that Q3. And there can't obviously be another one. All right?
Yeah.
So just remember that median and Q2 are the same. Okay. So another way of saying the exact same thing is Q1 separates the bottom 25%. Okay. Q2 separates the bottom 50% from the top 50%. Q3 separates the bottom 75% and you have the top 25% left. All right. So now what we're going to do is we're going to use the data from the Superbowl example to determine Q1, Q2, Q3. So let's go back here. Is that data sorted? It is not sorted. Yeah. So we have to first sort them. Okay?
Okay.
And I can help you sort them. We're going to have to do the whole thing.
So should we create a new document or should we do
We're actually going to do it by hand.
Oh.
Yeah.
Okay.
So we have to sort this, right, in increasing order first. All right, so it's 14, and then there are 13 16s. 3 16s. 17. 20 appears 3 times. 21 twice. 23 twice. 24 3 times. 26 1 time. And then there are 4 27s. 29, 30. Let me stop this so I don't waste. So there are 42 data points. So first we have to find the median, which is right down the middle. So if there are 42, it's 21, 21. So after the 21st one, right? So it's 16 in the first row, 17, 18, 19, 20, 21. Here, that's the median, right? That is Q2 right there. Okay, so now there are 21 before that slash, 21 after that slash. So that's strictly down the middle. And then now I need to divide the first one in half. So if there are 21 values in the front here, half of that is what?
11. 10 and a half.
10 and a half. So which number is that going to be?
Maybe in the middle of the last 35, right?
No, in between 21 and 21.
It's going to be the 23, right?
Oh,
if there are, okay, so if there are 21 numbers.
Is it from the 29 backwards?
Right, so it's everything starting from the 14 to the 29.
Yeah, that's what I thought.
Okay, so this number here, look. So that number there, so basically it's the 11th number. So here's what I do. It's 20, there's 21 of them, right? If it's an odd number, subtract 1. That's 20. And now you have to do 10 on each side of that. Okay? So look at that circled 23. There are 10 before it and 10 after it. So that's my Q1. And then here there is also 21. Again, it has to be the 10th one. And that's that. It has to be the 11th, so it's that number, the second 35. The third 35. Okay? So Q1 is 23, Q2 is 30, and Q3 is 35. All right? Now, and a very, very important interpretation is what we call the 5-number summary. The 5-number summary always has the same 5 numbers, the minimum value, Q1, Q2, Q3, and the maximum value. All right? So for those same data points up there, what is the 5-number summary?
14.
Well, right. So you say minimum is 14. Q1 is 23. Q2, 29.5. Q3, 35. Maximum, 55. That, well, you don't have to put it in brackets, but that is the 5-number summary. Do you see why Q2 is 29.5? Because it fell right in the middle of 29 and 30, so we had to take the average. Okay? All right, so that's that, and then the handout is homework. I have a handout for
So what
homework.
do we do next